In this video, we will go over the basics of shaders. What is a shader? I think the more important question is actually why is shader? Imagine how pixels on the screen works. Let's say we have a 2x2 display. Those pixels, they need to know what color they should be displaying. We go to pixel x0, y0, and we say, this guy should be black, and we go to x1, y0, and then we say this pixel should be white, maybe. And we go over all four of them and then give them a value. That would work. But then we meet a little problem. You see, 2x2 is 4. But for a common 1980 times 1080 display, this value goes to 2 billion, which is a big number. And imagine having to calculate through all 2 billion pixels every single frame 60 times a second. Even with the most powerful CPU, that's not gonna cut it. So our solution is parallel processing. The CPU is a very powerful calculator, very powerful computer. You can throw a lot of very heavy calculation at it, and it can spit out the result really fast. But with parallel processing, we're not using a very powerful computer. We're using many weak computers. They are very weak on their own, but because we have a lot of them, by the time one pixel is done, rest of the pixel is also done. So effectively, every frame, it just takes the time of one calculation. That's how GPU, graphic processor unit, works. But with parallel processing, there's two caveats that you need to be aware of. One is that every of these tiny computers, they have no idea what other computers are doing. I deal with the pixel x0, y0. I have no idea what is going on with the pixel x1, y0. Effectively, I don't even know that it exists. And you can't calculate a result, put it in the RAM, and then retrieve it later. Effectively, it does not have an idea of time. So let's actually make a shader and see what's going on. Frag coord is the coordinate of this pixel. Imagine you are that tiny computer. You just know your position. Frag color is the output. Red, green, blue, alpha. Let's try put the frag coord in here. You'll see that the entire screen is red. Red color brightness of 0 means there's no red light. A red color brightness of 1 means that it is at its maximum brightness, right? So our frag coord, for example, this guy here may be something like 5200. This guy 5 is above 1. You can't make a color brighter than your maximum brightness, right? So this 5 just get cut down to 1. So it's maximum red color here. Let's try something like this. What is the pixel on this black part thinking? Well, the coordinate is 100 to 100, so, right? So the frag coord x is 100 minus 300, which gives us negative 200. Below 0 is just gonna be cut to 0. And what's the pixel on the red side thinking? Well, let's say this coordinate looks like 400, 200 maybe? So 400 minus 300, which goes out to about 100. So 100 is way above 1 and way above maximum brightness, which gets cut down to 1. The pixels on the red side doesn't know there are black pixels. The pixels on the black side doesn't know there are red pixels. The pixels only know about themselves. They don't know about anything else. So we are seeing a line here, but the pixels are not aware of that line. We can do the same thing with Y. So let's see what the shader toy template is doing here. frag chord divided by I resolution. Let's say my position is something like 4030 maybe, and my resolution 400 300. 40 divided by 400.1, 30 divided by 300.1, so the UV value is x.1, y.1. And if my coordinate is at 0 0, UV comes out to still 0 0. If my coordinate is on 400 300, it's gonna come out to 1 1. The UV is confined within 0 to 1. This is called normalize. So if we try to render UVX, you'll see that for pixels around here, the coordinate is something like 5200. So 5 divided by 800 here is close to 0, and 200 divided by 450 here is about 0.5. So for my X value, the UVX is close to 0. The red brightness close to 0, it's black. For pixels around here, the X value for the UV is close to 1. A red brightness of close to 1 means that the red is almost to its maximum brightness. So it makes a very vibrant red. I have made all red, green, blue use this brightness variable I just made. It's just the same thing we talked about before. Let's try make a circle. If you remember from I think high school, the formula for circle x squared plus y squared. Let's see what this does. For pixels here, my frag chord is 10 10, and then divided by 800 450, close to 0. 0 squared plus 0 squared, and square root of that, it's still 0. Our brightness here close to 0, so they're black. How about a pixel around here? This pixel is 800 450. That divided by 800 450, we get 1 1. So the UV value is 1 1. 1 squared is 1 plus 1 squared, so that's 2. Square root of 2 is something around 1.4. These pixels that have white colors, their distance away from 0 0 is above 1. I want to move the center of the circle to the center of the screen. So what we can do is make a vec2 pos. Vec2 means 2D vector. I offset it by half and half here, and then use this pos instead of UV. Now the circle is in the center of our screen, and I want to introduce you to a very useful function called step. Step is a very common function in shaders. What step does is that it takes an edge and a value. If the value is smaller than the edge, step returns 0. If the value is greater than the edge, step returns 1. Let's use the edge of 0.5. So what is actually going on here? Well, let's see. For some pixels inside of the circle, my coordinate is something like 450 300 divided by 800 450 comes out to about 0.6 0.6. 0.6 minus 0.5, which is 1, and 0.6 minus 0.5, which is 0.1. So our pos is 0.1 0.1. 0.1 squared plus 0.1 squared is 0.02. This value is below 0.5. Step returns 0. Our brightness is 0, so we see black. For some pixels outside of the circle, it gets the coordinate of 800 450. Okay, so 800 450 divided by 800 450 comes out to 1 1. 1 minus 0.5 is 0.5. 1 minus 0.5 is 0.5. So pos is 0.5 0.5. So 0.5 squared, which is 0.25, plus 0.5 squared, also 0.25, the square root of 0.5, which is a value higher than 0.5. Step returns 1. Our brightness is 1. So you see the white color. I recommend reading the book of shaders. It's free. You can sign up on ShaderToy. It is a popular tool for writing shader and rendering shaders. Read through the book of shaders, try to implement those ideas in ShaderToy yourself, run through about most of the pages, and you will be way more familiar with shaders. You don't need to do all of them, you just need to do most of them.